Welcome. This is Unit 1 pre-lesson over formulating systems of equations. Let's begin. First of all, a system of equations is a collection of two or more equations with the same set of unknowns. Now when we say unknowns, we mean variables. Variables like x and y, a and b, doesn't matter. You get to choose the variables. Most people are going to go with x and y. But you're going to write two equations, two equal signs, and each equation is going to have two variables in them, typically. Starting out with word problems as a means of writing equations. So that means you're looking at a word problem, there is no equation, and from all that information, we are going to write not one, but two equations, or more. First of all, after you've read the problem, you need to identify the unknowns. That usually is found in the question itself. It'll say how many of this, or how much did this cost, or whatever. But in the question itself, that will tell you exactly what is unknown. And now that you know what the unknowns are, let's assign variables to them. Variables again like x and y, a and b, again, take your choice. Then go back in the problem and look for numbers that correspond to each unknown. And you're going to use those numbers to write the equation itself, the equations themselves. So let's see an example of that. Sue buys 1 pound of apples and 2 pounds of bananas for $4. Juan buys 2 pounds of apples and 3 pounds of bananas for $7. How much do apples and bananas cost by the pound? Well, what are the unknowns? Look at that question right there. How much do apples and bananas cost by the pound? Those two things are unknown. How much apples cost per pound and how much bananas cost per pound. So, I know what my unknowns are. I just need to give them some variables. And we'll stick with x and y, so we'll say that x is for apples, and we'll say that y is for bananas. Now we just need to go back in this problem and take the numbers that are tied to each variable, each unknown, and then write that as an equation. Write the number with the variable. So let's start with that first sentence. Sue buys 1 pound of apples. Apples had 1 pound tied to it. So when I go to write my equation, apples is x. So with x, I'm going to put a 1. Continue back with reading it. 2 pounds of bananas. So bananas is going to get a 2 with it. Bananas is y, so I put a 2 with my y. And then lastly, it's for $4. So that's what it equals. It equals $4. 1x plus 2y equals 4. 1 pound of bananas plus 2 pounds, I said that wrong, 1 pound of apples plus 2 pounds of bananas is $4. Second sentence. Juan buys 2 pounds of apples. 2 pounds of apples. Apples is x. I'm going to put a 2 with my x. So I do that. 2x. Continuing on. 3 pounds of bananas. Bananas is y. I see a 3 tied to it, so 3 goes with y. And this is for $7, so that's what this equals. 2x plus 3y is 7. Or in other words, 2 pounds of apples plus 3 pounds of bananas is $7. Now with the graphs, it's a little bit more straight to the point. You just identify each line's slope and y-intercept. Once you know that information, you can write the equation. And the way you can write that equation is using that handy-dandy formula y equals mx plus b, where if you recall, slope is m and y-intercept is B. You identify those two things about any equation, any line, and you can write the equation. And that's what we're looking for at the end of the day anyway. So let's see an actual graph. We'll identify slope, we'll identify y-intercept, and use that to write an equation. Here's my graphs, really. Two lines. And we want to pick out the slope and the y-intercept. We'll start with this blue line. It's got a positive slope, and it's got a y-intercept up here somewhere. Again, y-intercept means where it touches the y-axis. So I count how many spaces up. 1, 2, 3. Y-intercept of this line, and you know y equals mx plus b. The y-intercept is 3. Now, to get the slope, the m, I need to count the rise over run. And that's from point to point. So I find a point here, and a point here, and how much does it rise, how much does it run? It's going up 1 and over 1. So the slope is up 1 over 1, or rise over run. I can simplify that to just 1. So for my first equation, I identified the slope, the m, is 1, 1x, and the y-intercept, the b, is 3, so plus 3. One equation down, one to go. For the green line, it does have a negative slope. I can tell this because it's going down. Negative slope, I can already write my negative sign here. And let's just take any 2 points and we'll identify the slope. So I see a point here, and I see a point here. So what's happening? We're going down 1, remember rise, and then over run. Rise negative 1, going down 1, and then we're going over 2. So my slope is negative 1/2. My m is negative 1/2. Then what's my y-intercept? This line touches the y-axis right here at 0. Well, I don't need to write plus 0. I can just leave it at negative 1/2x. Y equals negative 1/2x. And that's it. That right there is a system of equations.